today we're going to go ahead and look at 8.2. So that's what we're going to be looking at today, is 8.2. Now, this is a very, very important concept because you will be using the quadratic formula a lot in college algebra. It's one of the first things that you look at in your college algebra course. You do a lot of zero factor. Okay, that's very, very important. Remember, we did that in Chapter 5, and we solved those. Square root property that we learned about last class period, very, very important as well. And also the quadratic formula. And the quadratic formula is not too bad as long as you know where to put the numbers. So today we're going to be learning about what's called the quadratic formula. So we're going to be looking here at the quadratic formula. Find a better pen. And the quadratic formula, what we need to make sure is we need to make sure that your equation must look like this. So for the quadratic formula, your equation must look like this. ax squared plus bx plus c equals 0. Okay, and this is going to be our equation that we're going to use for the quadratic formula. And then your quadratic formula is this. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's our quadratic formula. Now, what we do is we make sure that it looks like this. That may require foiling. That may require moving parts around. But you have to make sure that it's in this order and that it's set to 0. Once it's in that order and set to 0, you find your pieces. We label those. We plug them in. And we calculate it out. And then on these, you're not going to use a calculator for the roots. You're going to break them down like we have done before. Remember, if it's a negative underneath that square root, it comes out as an I. So we're going to do a lot of these today because it's very, very important that you know how to work these out. So I'm going to pick a few from our textbook to look at. And we'll do one that's already in the correct form. So let's start with this one. Okay, this is on page 548. And we're going to look at this one. This is question 7. And this is 6x squared plus 11x minus 10 equals 0. All right? Now, the first thing we do, we're going to be using our quadratic formula here. So the first thing we do is we look and make sure that we can't divide anything out. And we cannot. Right? We got a 6, 11, and a 10. They have absolutely nothing in common. Now, what we do is we label our pieces. It's in the correct order. It's been set to 0. And this is our A. So A is going to be that 6. B is going to be that 11. And C is that negative 10. Now, we write up our formula again, and we plug our values in. So we just rewrite our formula. I always do that. What do we plug in? We'll look at your values. So my B is 11, so that's going to be a minus 11. And then we've got plus or minus. Then we have the square root here of b squared, so that's going to be 11 squared minus 4 times a, which is the 6 there, times c, which is a negative 10, all over 2 times the 6. Now, what we do when we work this out is we do it in parts. So the first thing that we do is we look at our discriminant. And our discriminant is everything that's underneath that square root. So the discriminant is just what is under the root. And what's underneath our root? Well, it's 11 squared minus 4 times 6 times a negative 10. Now, where students make a mistake at is they're not careful with the signs. And we have to be very careful when we multiply. And remember, what happens when we have a negative times a negative? Well, that is going to make that positive. So we start off with 11 squared. 11 squared is that 121. Now, count the number of negatives. Negative and negative, that's 2 negatives. That makes it positive. And then we just multiply the numbers together. So we have 4 times 6 times 10. Well, that's a 240. And then when we add that to that 121, you get now 361. Is everyone okay with that? So does everyone see what we're doing? You might want to pay attention if you're not, because it's very, very important that you understand how to use the quadratic formula. So now we have a negative 11 plus or minus. What we just found was that 361. And what's down below is 2 times 6. 2 times 6, that makes it a 12. Now, from here, make sure that that is not a square root, perfect square. If that's a perfect square underneath this square root, then it's going to come out. And it turns out that 361 is a perfect square. Use your calculator. 361, when we take the square root of 361, use your square root key, that gives you a 19. So now we have minus 11 plus or minus 19 over 12. And we break it up and we get our two solutions. So write it out separately and then break them down. So that plus or minus means we have a positive case and we have a negative case. So the first one we have is going to be a minus 11. We'll do the plus one first. Plus 19 over 12. Minus 11 plus 19. Watch your signs. Remember that 11 is negative. Add 19 to it. You get an 8 over 12. And 8 over 12, well, these have a 4 in common. All right, so 8 over 12. That leaves you now with, 12, we're going to divide that by 4 because they both have a 4 in common. And that leaves you with a 2 2/3. Right? 12 and 8 both have a 4 in common. 8 divided by 4 is 2. That's where that came from. 12 divided by 4 is that 3. So that is one of the solutions. What about the other one? Well, the other one is going to be minus 11 minus 19 over 12. And 11 plus that 19, they're both negative. They go together. And so that's going to make that now a minus 30 over 12. And reduce it down as much as you can. So 30 and 12, well, they both have a 6 in them. Oh, yep. Thank you, Tristan. I will get that all graded for you, and you're great at it. Okay, so we've got minus 30 over 12. Well, we know it's going to be a negative. These both have a 6 in them. So that's going to make it a 5 over 12 divided by 6 is a 2. So that is your other solution. What we're doing is we're going over the quadratic formula. We'll write it up again here in a minute. And we're going to do a lot of these today. So let's do another one. Very, very important because you're going to see these in college algebra quite often. We'll just do question 8. And this is on page 548. And again, we're talking about the quadratic formula. So let's review that again. Your equation must look like this. This is the quadratic formula. Your equation must look like ax squared plus bx plus c equals 0. And your formula is this. Your formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So that is our formula. So to use this formula, your equation has to look like this. So it has to be equal to 0, no parentheses at all, has to be in that order. And then we label our pieces and we plug them into the quadratic formula. Now, where students make a mistake at is in the signs. So if students make a mistake, it's generally in the signs. So let's do question 8. This is on page 548. We're going to look at question number 8. This one is already in the correct order. So we don't have to do anything first because it's in the correct order, right? It looks like this, doesn't it? It needs to look like that. Ours does. So this is going to be our A. So the 8's the A. The 10 is the B. And then watch your sign there. Keep that negative. That negative is your C. Now we apply our quadratic formula. I always like to write the formula down before I use it again. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to plug our values in. Now, watch for things like double negatives. So our b was that 10, so we switch our sign. So that's going to be a negative 10, right? That goes there. Then we have our plus or minus the square root of, bless you, 10 squared minus 4 times a, which is an 8, times c, which is a negative 3, all over 2 times 8. So it's pretty straightforward, but students generally make mistakes with the signs if you're not really, really careful. So let's work this out. Now, what we look at first is we look at our discriminant. And the discriminant is what's under that root. So we're going to do our discriminant first. And we've got 10 squared. Well, 10 squared, that's 100. Now, here's where students make a mistake. Watch the signs. Negative times negative. Negative and negative makes it a positive. So be very, very careful with the signs. So we know that it's going to be positive. And then we just multiply them. So 4 times 8 times 3, that's a 96. Add those together, and that's 196. So now we're going to rewrite what we've got. So we have now a negative 10 plus or minus, what did we find underneath the root? Square root of 196. And 2 times 8, 2 times 8, that makes it a 16. Now, check. In some cases, this is a perfect square. If it's not a perfect square, then you're going to have to break it down. So let's see if 196 is a perfect square. And we'll use our calculator, and it happens to be a perfect square of 14. So now we're going to rewrite this again. And that's going to be minus 10 plus or minus square root of 196 was 14 over 16. Now, we do need to get our two solutions here. And that's going to be minus 10 plus 14 over 16. And minus 10 plus 14. Minus 10 plus 14, that's a positive 4 over 16. And what does 4 over 16 reduce down to? These have a 4 in common, so it reduces down to a 1/4. There is one of your two solutions. Next one, minus 10 minus 14 over 16. Minus 10 minus 14, that makes it a minus 24 over 16. And what do these have in common? Well, in this case, they have more than just a 4. I believe they both have an 8 in common. So these both have an 8 in common. So that's going to make it now, when we reduce, a minus 3 over 2. So there are your two solutions. Is everyone okay with how I found the numbers, plugged them in, got my solutions? Now, those were nice because the roots broke down. In some cases, the roots may not break down. So, for example, question 14. Question 14, we're going to be left with the square root. So that is 2x squared plus 3x plus 1 equals 0. Is it in the correct form? Yes. What does it need to look like? Okay, for this to work with the quadratic formula, it has to look like this. Does it look like it's the correct form? Yes. If it's not equal to 0, you move things around until it is. If you've got parentheses, you have to FOIL them out or distribute to get rid of them. No parentheses, and it better start with the x squared. So what do we know? We know this is going to be our A. This is going to be our B, and it's positive there, right? So make sure you see the signs. This is our C. We write up our formula one more time. So x equals minus b plus or minus the square root of b squared minus 4ac over 2a. And we now start plugging our values in. So in this case, our b is a 3. So that's going to be a minus 3 plus or minus the square root of 3 squared. And you could put parentheses around it. The 3 if you want. You really don't need to unless you've got a negative. If you have a negative, make sure you put it around that number. In this case, it's positive, so it really doesn't matter. And then we've got a minus 4, A, which is 2, C, which is 1, all over 2 times A, and A in this case is a 2. Let's make sure we copied everything down correctly here. Oh, wait. Sorry about that. I did make a mistake. When I copied down, there should be a minus. My mistake. That should be a minus. So if you look at the textbook, I wrote it down wrong. It should be a minus there. Okay, so make sure you're careful with the signs. It's so easy to make a sign error. Now we do our discriminant separately. A lot of times, I just abbreviate the discriminant, DISC. That's going to be our discriminant. And all that is what's underneath our root. So we've got 3 squared minus 4 times 2 times a negative 1. So that's 9. Double negative here makes it again positive. 4 times 2 is 8. Times 1 more makes it still an 8. Add those together and we get the square root of 17. So now we can rewrite this as minus 3 plus or minus the square root of 17. 2 times 2 makes it a 4. Now, the last ones, they came out as a perfect square. And then we had to get the individual fractions. But what about 17? Is 17 a perfect square? No, right? We use our calculator to check. It is not a perfect square. Now, does 17 break down at all? No, because 17 is a prime number. So there's really nothing else we need to do. You can leave it like this, or you can split it up into the 2 parts. So you can either leave it like this for your answer, or you can split it up into the 2 separate fractions like this. Because it's actually minus 3 plus the square root of 17 over 4. And minus 3 minus the square root of 17 over 4. But this is okay to leave it like this. Usually in college algebra, you'll leave it like this. So that's the way they normally write it. But it's actually this. So if the roots don't break down, it's usually a little bit easier. Let's do one more of these where it's set up correctly. Let's look now at how about question 22? So this one we will have to rewrite a little bit. So it's not quite set up correctly, but we do need to make sure that it's in the correct order. And we've got 26r minus 2 equals 3r squared. So what we need to do is we need to make sure that it's set to 0. Currently it is not. And you also want to make sure that the squared number is positive. If it's negative, you have to divide it out to get rid of it, which we'll do one of these in a moment. But this is not set to 0 yet, so let's go ahead and try to set this to 0. So I'm going to move that 26r over and the 2r, and the 2 over. Now, when I rewrite, then I get 3r squared minus 26r plus 2 when I rewrite it, and that now equals 0. So I just moved those over, and I write the 3r squared on the left. That came over, and that came over. Now it's in the correct order. So this is our A, this is our B, this is the C. So always need to make sure that you're careful with the sign. So this is a minus 26, so make sure that's why I circle it, to make sure that negative is included. Write up our formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. We plug our values in. So what's going to go in here? Now, be careful with that b. You may have double negatives. We have a negative from here. What is b? Negative 26. So that is why we have the double negative. So that double negative is very important. So watch out for things like that. If students make a mistake with the quadratic formula, a lot of times it's with the double negatives. Then you've got plus or minus the square root of b squared. Now, use parentheses. So that's going to make it a minus 26 squared with parentheses. Minus 4 times your A, which is 3, times C, which is that 2, and that's all over 2 times 3. Square root goes over all of it. Now we're going to rewrite this again, and we do our discriminant separately. So what's in our discriminant? Minus 26 squared plus 4 times 3, or sorry, minus 4 there. Right. Make sure you copy the signs down correctly. Minus 4 times 3 times 2. 26 squared is 676. Now, why is it positive? Well, it's a positive 676 because what happens when you square a negative? When you square that negative, it comes out to be positive, doesn't it? We have a single negative here, so that stays negative. And then we have 4 times 3, which is 12, times 2, that makes it a negative 24. And 676 minus 24 is 652. Be very, very careful with the signs. The double negative in front of that 26 here is going to make that positive. So when I rewrite it, I'm going to have 26, so it's a positive, plus or minus the square root of 652 over 2 times 3, which is a 6. Now, unlike the last one, when we had that 17, 17 did not break down. But 652, well, it will. So how is 652 going to break down? Well, 652, we know it's an even number. Now, we could start with 2, but let's start with 4 because 4 is a perfect square. So let's see if 4 will go in here. And it does. So now we got 4 and 163. And we might be able to break this 163 down by using a 3. 3 won't go in there. 7 won't go in there. No number will go in there. 9's not going to go in there because 3 did not. 7's not going to go in there, so no number will go in there. But what do we know about 4? 4 is a perfect square of 2. Now we're going to rewrite it. So here's what we've got. We've got that. We broke it down. So now when we rewrite this, we get 26 plus or minus. Now, this is going to break down because a 2 comes out. Okay? So that 2 came out in front. What's left over? Square root of 163. And that is all over now 2 times 3, which is that 6. We're almost done, but we do need to break this down if possible. And there's different ways of doing it. I'm going to have you do it by factoring. When we have a 26 and a 2, we just look at the numbers that are in front, these whole numbers. 26 and 2, they both have a 2 in common. So I'm going to factor out a 2, and that's going to leave you then with 13. Plus or minus, the 2 came out, so that's the square root of 163 over that 6. And that 2 and that 6 can cancel. And that leaves you then with a final answer of 13 plus or minus the square root of 163 over 3. That's all that we can do. We factored out that 2, and we factored out that 2. That allowed us to reduce it with that 6 below. And again, we're doing a lot of these because you will see a lot of this in college algebra. I really don't think we can do too much of the quadratic formula because it's very, very important. Let's do one that has fractions. Let's look at 24. So question 24. What we have on 24 is we have p squared plus p over 3 equals 1/6. One thing you never, ever want to do is put fractions in the quadratic formula. So anytime you have fractions, they need to go away. And how do we do that? Well, we look at our denominators. And what do we have? We have a 3 and we have a 6. So I'm going to multiply everything by a 6. That's going to make it to where we clear out our fractions. So remember how we cleared the fractions. That's what we're going to be doing. So that gives us then 6p squared. 6 divided by 3 is 2. So that's a plus 2p. And 6 and 6 cancel, leaving you with a 1. This is not in the correct order yet. It needs to be equal to 0. This one is not. So let's go ahead and move that 1 over. Now we can rewrite this in the correct order. So now we have 6p squared plus 2p minus 1 equals 0. Label A, B, C. Make sure it's equal to 0. Make sure it's all in the correct order. If it begins with a negative, which we'll look at one here in a little bit that does, you're going to have to divide it out and get rid of it. In this case, we didn't have to because that 6 was positive. So let's write up our formula. X equals minus b plus or minus the square root of b squared. There's 4ac all over 2a, which is then minus 2 plus or minus the square root of 2 squared minus 4 times the 6 times the negative 1 all over 2 times the 6 there. All right? Break it down. Do your discriminant first. And that's 2 squared minus 4, 6 times minus 1. 2 squared is 4. And then we've got 4 times the 6. That makes it a negative, and negative makes it a positive. So that's going to be a positive 24. All right, we're going to add those together. And that gives you a 28. So then we have 2 plus or minus the square root of 28 all over 2 times 6 makes it a 12. Now, is 28 a perfect square? No, it is not. But can we break it down? Yes, we can. 28 is an even number, so let's try a 4. Always try a 4 or a 2 first. If possible, you want to use a 4, because 4, we know, is a perfect square of 2. So that's coming out. And 28, when we divide it by 4, that's a 7. So rewriting now, we get, and this again is x equals here, we get a minus 2 plus or minus. We're going to take that 2 out. So that's 2 square root of 7 over 12. And we need to do one more step to finish it out completely. These both have a 2 in common. So I'm going to factor out a 2. 2 divided by that 2, that leaves you with a negative 1. Plus or minus, that 2 comes out. Leaves you with a square root of 7. And that's over 12. 2 and the 12 can cancel, but leaves you with a 6. So what's my final answer? Minus 1 plus or minus the square root of 17 over 6 there. So that's what we've got. That's your final answer. You could break it up into separate pieces if you wanted to, but you can leave it just like this because that's how you'll be leaving them for the most part in your college algebra course. Let's look now at one where we have to FOIL. How about we look at question 30? So some of these require a little bit of algebra first. Some of these we're going to have to try to FOIL first. We've got to make sure that we do that. So we're going to look now at question 30. And that's x minus 5, x plus 2 equals 6. Now, for that quadratic formula, we're using the quadratic formula. That's all we're doing. So, for the quadratic formula, we cannot have these parentheses. So, how do we handle those? Well, we are going to have to FOIL. So, this has to be broken down. So, we're going to have to FOIL. And we've got x minus 5, x plus 2, and so we're going to FOIL. So we'll do that over to the side. X times x is an x squared. X times 2, that's a 2x. Negative 5 times x, that's a minus 5x. Negative 5 times 2, that makes it a negative 10. Those can go together. And that is then x squared minus 3x minus 10. So we've gotten rid of the parentheses. To work this out, it needs to be equal to what? Well, it really needs to make sure it's equal to 0. Okay, so we're going to go ahead and have to move that over to set it to 0. That over, we get x squared minus 3x minus 16 equals 0. And if there is no number in front of the x squared, we put a 1 there. So there is no number in front of the x squared, so we put a 1. So that means your A is the 1. Negative 3 is your B. Negative 16, that's your C. So we have all of our pieces. We've got them all lined up, ready to go into the quadratic formula. So let's write up our formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And that is then a negative of a negative 3. So watch your signs. This is where students make a mistake at, is here. Negative of negative. And we've got a plus or minus b squared, so that's a minus 3 squared minus 4 times a, which is 1, times c, which is a negative 16, all over 2 times 1. Work with your discriminant. When you square this negative 3, the negative is inside. So 3 squared is 9. So it's negative. So we square a negative, makes it positive. Double negative here makes that positive. and we've got 4 times that 16. It's going to be a positive 64. We add that to your 9, and we get a 73. We know the double negative here. I'll circle it with a marker so we can see it. This double negative here, well, that's going to make that positive. And so now we've got a positive 3 plus or minus the square root of 73 over 2 times 1, which is a 2. And we need to see, can we break down 73? Well, 73 ends in a 3, so we're going to try a 3. 3 does not go in there. 73, we'll try a 7. 7 does not go in there. 15 is not going to go in there. We just try different odd numbers until we find one, if possible. We could try 13. Won't go in there. 17 will not go in there. So is 73 going to break down? No. If it doesn't break down, then we are finished. So there would be your answer. But always, always check to see if you can break down that root. In many cases, you can. All of these have had real solutions. Now we're going to look at one that's going to give us an imaginary solution, complex number. Question 41. X times 3x plus 4 equals a negative 2. Nothing new. What are we going to do with that x that's in front? Well, we can't have parentheses, so that x in front has to be distributed through. And that is then 3x squared plus 4x equals a negative 2. We're going to add that 2 over. Now we're left with this. 3x squared plus 4x plus 2 equals 0. Okay. Now, what are we going to do from here? Well, from here, it's set to 0. It's in the correct order. So this is your A. This is your B. This is going to be your C. Write up our formula. And plug the values in. This one, though, is going to give us an imaginary number. We're going to get an I. So when we write up our formula, we have x equals a minus b plus or minus the square root of b squared minus 4ac all over 2a. Plug in your values. B was 4, so that's going to be a negative 4. It's positive 4, so plug it in as a negative 4 here. Then we have a plus or minus. We have the square root then of b squared, so that is 4 squared. Then we have a minus 4. A, which is a 3. C, which is a 2. And that's all over 2 times your 3 there. Let's go ahead now. Clean it up. We do our discriminant first. And that was 4 squared minus 4 times 3 times 2. So that's 16 minus. Now what about here? 4 times 3 is 12. Times 2 makes it a 24. And be careful with your signs. 16 minus 24, well, that's a negative 8. 2 times 3, that makes it a 6. Now, this is a little bit different because we have a negative underneath that root. Now, remember, if it's negative underneath the root, we need to bring out an I. Remember that way back from chapter 7? So we're going to look at that 8. Always start with a 4 if it's an even number, if possible. So 4 and 2. 4 breaks down into 2 and 2. So those come out. So now we have 4 plus or minus. A 2 is going to come out. This is negative, so an I also comes out. Square root of 2, and that is over 6. For these, this is what's called a complex number. So for these, I want you to rewrite it into the separate parts. So rewrite this as 4 over 6 plus or minus 2i square root of 2 over 6. And then I want you to break it down. So you write it out, you break it down. Now, what about minus 4/6? Well, minus 4/6 breaks down into minus 2/3. So you always want to break these down whenever you have an I. You split it up. And then that 2 and that 6 can reduce to make it a 3. So plus or minus comes down. Now, a lot of times if we have a fraction, we put the I at the end. So that's going to be the square root of 2 over, we reduce it down to 3, I at the end there. And that's as far as you can go. So with the i's, you need to separate it out into 2 fractions. And we normally put the I behind the fraction. Okay, let's look at one more here. How about we look at question 46. 46 is not really the hardest question, but it's the one that takes the most time. So this is 4x plus 3, x minus 1 equals x plus 3, x minus 6. Now, why is this one going to take so much time? Well, this one is going to take so much time to go through because we are going to have to FOIL this out twice. FOIL the left, FOIL the right, put it all back together, set it to 0, use the quadratic formula. So this is probably the most time-consuming one. I didn't give you one this difficult on your homework or this time-consuming, but in college algebra, you're going to see them. So I want to make sure we at least go over one of these because this is something that a typical college algebra student would see. Within probably the first week or 2 of class, you'll be doing these. So let's remember what we would do. Well, we can't have parentheses for the quadratic formula, so we're going to begin by FOIL. So 4x plus 3, x minus 1. FOIL this out. 4x times x, that's a 4x squared. 4x times a negative 1, that's a minus 4x. 3 times x, that's a positive 3x. 3 times a negative 1, that's a negative 3. We put the middles together, and that is 4x squared minus x minus 3. So that's this side here. We repeat the process on the right-hand side. Again, it's not difficult. It just takes time. So now we've got x plus 3, x minus 6 on the right-hand side. We're going to FOIL this out again. and that's x squared minus 6x plus 3x minus 18, and that is x squared minus 3x minus 18. So I'll give you a second to digest that. So what did we do? We had to FOIL both sides out. So we did that. So that required us to FOIL twice. Now, if we want to use the quadratic formula, what must we do? We must make sure that it equals 0. So we're going to move everything over to make it equaling 0. And I always like to move everything to the left. So we're going to take off an x squared here. We're going to add 3x here. And we're going to add 18 over here. Careful. Remember, this is a 1x squared here. So what do we have? We have 4 minus 1. 4 minus 1, that makes it a 3x squared here. Minus 1 plus 3. Minus 1 plus 3, that leaves you with a 2x. Minus 3 plus 18, that leaves you with a 15. Everything cancels out on the right. So now equals 0. Okay, let's go ahead and get our A, our B, and our C. So there's your A, there's your B, there's your C. We can now apply our quadratic formula. So let's do that. And that's x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to be careful when we plug our values in. We need a negative b, so that's a negative 2 plus or minus. We have a square root of 2 squared minus 4. A, which is 3. C, which is a 15. And that's all over now 2 times the 3 there. So what do we have left? Well, we now have minus 2 plus or minus. We'll do our discriminant first. Let's do that over here first. And then I'll rewrite it. So let's do that first. Always do discriminant first. And that's 2 squared minus 4 times 3 times your 15. Again, be very careful about your signs. So that's 4 minus 4 times 3 times that 15. A single negative makes it negative. And that's a minus 180. And that leaves you with a minus 176. Now we can rewrite this as a minus 2 plus or minus the square root of a minus 176 over 6. And see if we can't break down 176. And I'll slow down a bit so we can get caught up here. But you see what we did. Okay, we had to FOIL everything out. It took a little bit of time. I didn't put one of these on your homework, but you'll see something like this in college algebra. You have to FOIL the left, FOIL the right, set it to 0. Then we applied our quadratic formula. We labeled our pieces. And we did that up here. Put them into our formula. We worked out our discriminant first. Break down 176 because it's an even number. So again, we're going to try 4. 4 and 44. Well, let's go 4 again. So let's try a 16. You want to get the biggest number possible. So that's 16 will work. It's a perfect square. So if 4 goes in there, let's see if a 16 will. We know 16 is a perfect square of 4. So those two 4s come out. So we now have minus 2 plus or minus. We have a 4. We have an I that comes out because of this negative here. And what's left over? Square root of 11. And that is over 6. Split it up and reduce it down if possible. Why do we split it up? Because this I, so that's minus 2 over 6, plus or minus 4, I, square root of 11 over 6, reduce, negative 2 over 6, that reduces down to a minus 1/3, and then we have our plus or minus, 4 and that's 6, that reduces down to be a 2/3, right? So that's 2 square root of 11 over 3, and then we always put our I at the end on these fractions. So there's your final answer in the correct form. You always split up the real part from the imaginary part. We do have a little bit of time left, so I'm going to go ahead and pass out your practice final and your take-home final, and then we'll look at a couple of questions off the practice final. Next week, what we're going to be doing is we're going to be going over this. We'll spend the entire next week getting ready for our final. I like to do that because I want to make sure everyone does well in their final. And I realize your other classes have homework that's due. In this class, I want you to focus just on that one. Okay. So, what we have is we have a practice final and we have a take-home final. And this is all due when we take our final exam. I've got a schedule over there as well, the final, which I'll pass out in a moment. But just so we know, this is our practice final. All right, you get 15 points for doing this final, practice final. That's a given. If you complete it and you do work, you get the 15 points. The take home is 100 points, and it's behind the practice, and it's here. And this is graded, so this is worth a normal exam. So that's going to be worth your normal exam. Next week, we're going to be working on the practice final. We're going to be making up a key. But you can go ahead and check your answers now with the answers here. But next week, we're going to be working on a worked out key. So you'll know exactly how I did each one of them. Your final exam is going to be worth 300 points, so it's worth a lot. You're going to know exactly what is on there, though. No surprises, no hidden questions. You're going to be allowed to use a page of notes or note cards, just like in any other exam. There'll be 30 questions. So there's 40 on your practice and take-home final. I'm going to cut that down to 30. But from these 40, you'll be 30 of them. When you look at your practice final and you look at the take-home final, they are very, very similar. So there's not much difference at all. I'm going to go ahead now, before I forget to, and pass out your final exam schedule. You're welcome. And just make sure you come to class on the time that your final exam is. Let's make sure we know what time our final is going to be at. And again, I just keep going it over with everyone because I don't want anyone to be here on the wrong day. So, when is our final? Well, our final is going to be we meet at 9:30. Okay, so we meet at 9:30 on Tuesday, Thursday. So that means our final exam is going to be 8 o'clock on Thursday, May 11th. So that's when our exam is, 8 o'clock Thursday, May 11th. You're going to have 2 hours to take your final. If for some reason you really don't feel like you can get it done in 2 hours, talk to me next week sometime. We can find some time for you to take it in the library, as long as it's done before that Thursday. If you want to take it in the library and have extra time. So if you don't think you can get it done in 2 hours, you should be able to, because most students do very well on the final. You know exactly what's going to be on there. All right, there's 40 questions. Of those 40, I'm going to change the numbers, and I'm going to cut it down to 30. That's what you're going to have. No surprises. You can have notes or note cards. So you're going to know exactly what's on there. So usually it doesn't take students more than about an hour for that exam, because you're going to already know what the questions are. But if for some reason you feel like you might need extra time or don't want to be stressed out over the time, talk to me. We can find some time for you to work on it, maybe anywhere from Monday through Wednesday in the library if you want. Otherwise, we'll meet at 8 o'clock on Thursday. Very important that you're here at 8 o'clock as well. So make sure you're here at 8 o'clock. That way everyone can start the test on time. I'm going to go through a couple of these questions. We've just got a few minutes, so I'll probably work out 2 or 3 questions. We'll do the rest of them starting next week. So starting next week, we're going to focus on the practice exam. So I'm just going to pick out a couple of them just to kind of refresh our memory. We're going to go through all the rest of them next week. So just to kind of refresh our memory a little bit about factoring. Let's look at 23. We'll do 2 factoring ones today, and we'll do, again, all of them next week. So let's look at our practice exam. Make sure this is our practice one here. I'll have to take them. Yep. Okay. Practice exam, question 23. We'll do some factoring ones today. This is what we've got. So your final is going to have a little bit of everything. So there will be some factoring questions. There will be some graphing questions, some inequalities. There'll be some square roots. So again, it has a little bit of everything. When I went through it, I made up a new final. This final has just a little bit of everything. So absolute values are on here. Square roots are on here. Again, it's just a little bit of everything. So we'll just look at a factoring one today to start off with. A lot of factoring. Factoring is very, very important. We'll start off with this factoring one. And it's not set to 0. Okay, there's no equal sign. So we can't solve it. All we can do is factor. When we factor, what is the first thing that we do? If I gave you this and I said factor it. First thing we do is we look at all the numbers together. We look at 24, 20, and 24 here. And we try to find the largest number that's going to be in common with all of them. But when we look at 24 and that 20, the largest number that they have in common is going to be a 4. So we're going to factor out this 4. Now, what about the negative? We want to make sure we factor out a negative. Why? Because you always want to begin the x squared part with a positive value. So we're going to factor out that negative 4. That's going to switch our signs. So negative 24 divided by negative 4, that leaves you with a positive 6x squared there. Negative 20 divided by negative 4, negative and negative makes it a positive 5x. 24, divide that by 4. Well, 24 divided by 4, that leaves you with a, it's negative. Negative divided by positive makes it a negative. negative 6. Now we need to see if we can factor it further. It might be that it won't go any further. I think this one will. So we should be able to go a little bit further on this one. We should be able to factor this trinomial. We factor out that negative 4. And we're going to try to factor it further. So let's see what we can do. And it will factor out. First times the last is a negative 36 here. Remember our rules about the signs. It's negative in the box, so what do we know? Are they different signs or are they the same? How can we multiply to get a negative number? Well, 2 negatives makes it positive, right? So that's not going to work. How can we multiply to get a negative? 1 positive, 1 negative. What's the sign in the middle? Positive. So that's our larger number. And let's just start working. What do we know about 36? Well, 36, it's an even number. Let's start with a 4. 4 and 9. Why did I start with 4? Because it's an even number. You could have started with 2, but I tried 4. Now, 4 and 9. Does that give me 5 when we subtract them? Yes, it does. So what's my 2 numbers? Positive 9, and negative 4. Can I jump to my factors? No, I have to factor this now down by grouping. So that's going to leave you with a 6x squared, a positive 9x, a minus 4x, and a minus 6. Factor. What can come out of the first 2? These have a 3 in common, so a 3x comes out. What's left over? 2x plus 3. Remember how we did these? The negative here. Both of them are negative. 6 and 4 have a 2 in common. So we're going to factor in a negative 2. And that leaves you then with a 2x plus 3. Those are the same. So that comes out as a 2x plus 3. Gone, gone. What's left over? 3x minus 2. And do not forget, what's out front of all of it is a negative 4. And there is your final, fully factored answer. I think we've got enough time to just do one more of these, and then we'll work more on this next week. So very important that you're here next week so you can see how we worked all these out. Here's the sign-in sheet. You're welcome. So make sure you pass it around. Okay, so let's work out another one. Now that was question 23. Let's do another factoring. Let's look at question number 26. Okay, this will be the last one that we're going to look at today. There's lots of factoring questions. There's a few graphing questions. We've got some absolute values. Everything we've covered is in here. A lot of factoring, though, because factoring is very, very important for college algebra. It's been a bit since we've done one of these. I need to factor this. It's not set to 0, right? We cannot solve it. We just want to factor it down. The only y that we have is that y squared. And we've got 4 terms. So when we have 4 terms, we need to factor it either by grouping or some way. So I'm going to group these first 3 together. And the reason why I'm doing that is, what do we know about 25 and 9? Well, that 25, and that's a 25x squared, by the way. 25 is a perfect square of 5 and 5. So that's going to make it 5x and 5x. 9 is a perfect square of 3 and 3. What's the sign in the middle? Negative. This is what's called a perfect square trinomial. And we found out that 25 was a perfect square of 5. So that makes it a 5x. And then what about what about the 9? 9 is a perfect square of 3. So that is then going to break down into 5x minus 3. Now, double check. 5 times a negative 3, negative 15. Double it, you get the negative 30. So we know it works. And we're not quite done yet, because what do we know about this? Well, we know this is negative. These are both squared. So this is going to be a difference of squares. And what does that break up into? 5x minus 3. 5x minus 3, we've got a plus and a minus. Y squared is a perfect square of y and y. And so there is your fully final factored answer. That's as far as you could go. All right, we're going to go over more of these starting next week. So make sure you sign that sign-in sheet. And I will see everyone then on Tuesday of next week. And we're going to be going over